In Module 8, we will discuss systems of linear equations in two variables and related word problems. In Module 8, Section 1, we will discuss solving systems of linear equations by the substitution method. The substitution method can be used when an equation is solved for one of its variables. Once that occurs, then we substitute that new expression for the variable into the other equation and solve for the remaining variable. Let's try an example. Solve the system using the substitution method. We start with two equations, 3x minus y equals 6, and negative 4x plus 2y equals negative 8. In order to use the substitution method, we must first solve one of the equations for one of its variables. Let's start with the first equation and just try to solve for y. To do so, we would have to move the 3x to the other side of the equation. So we subtract 3x from both sides. The opposite 3x's cancel, and we are left with negative y equals negative 3x plus 6. At this point, we would divide both sides by negative 1, meaning we divide every term by negative 1, and that gives us y equals positive 3x minus 6. At this point, we would want to take the expression 3x minus 6 and put it in place of our y variable in the equation that we haven't yet used. Let's do that on the next slide. That would give us, remember, y equals 3x minus 6. Plugging into the second equation gives us negative 4x plus 2 times 3x minus 6 equals negative 8. We then distribute 2 into the parentheses, and we get negative 4x plus 6x minus 12 equals negative 8. We combine like terms on the left-hand side, giving us 2x minus 12 equals negative 8. We then isolate x. So we add 12 to both sides of the equation. The opposite 12s cancel. We're left with 2x equals 4. And once we divide both sides by 2, we have x equals 2. Now once we have a value for x, we take that value into any of the original equations. Let's plug into the first equation. So that gives us 3 times 2 minus y equals 6. 3 times 2 is 6. So we have 6 minus y equals 6. Now we isolate y. So we subtract 6 from both sides, cancels on the left-hand side, and really it cancels on the right, so we put a 0 placeholder. We then divide both sides by negative 1, and we are left with y equals 0. Now your answer should always be in the form of an ordered pair in this equation, because really what this means is the point of intersection for these two linear equations is the point 2, 0. In short, this is the step-by-step process for solving linear equations, a system of linear equations, using the substitution method. Step 1, we solve one of the equations for one of its variables. Step 2, we substitute that expression for the variable found in step 1 into the other equation. Step 3, solve the equation from step 2 to find the value of one variable. Step 4, substitute the value found in step 3 in any equation containing both variables to find the value of the other variable, and then we can check the solution using the original system. Let's try another example. Here we have y equals 2x minus 5 and 8x minus 4y equals 20. Our first step is to always isolate one variable in either equation. In this case, our first equation is already solved for one variable. Y is already by itself. So we take the expression 2x minus 5 and put it in place of y in the next equation. Doing so will give us 8x minus 4 times 2x minus 5 equals 20. We'll then distribute the negative 4 into the parentheses. And we're left with 8x minus 8x plus 20 equals 20. When we combine like terms on the left-hand side, 8x minus 8x is 0. Those cancel. And we're left with 20 equals 20. Whenever the variables cancel, we are either going to be left with a true statement or a false statement. In this case, 20 always equals 20, so this is true. True statements mean that your two lines are actually the same exact line. It's just the equations are written in a different form. So in this case, we would say that we have infinitely many solutions, meaning that because these are the same lines, they would lie right on top of the other. Let's try another example. 3x minus y equals 4, and 6x minus 2y also equals 4. Let's try to get the first equation with one variable isolated. So we write 3x minus y equals 4. I'm going to isolate y. We cancel the 3x's and we're left with negative y equals negative 3x plus 4. We divide both sides by negative 1. And that gives us y equals 3x minus 4. We can then take that expression and plug it into the y value, the y variable, in the second equation. That will give us 6x minus 2 times 3x minus 4 equals 4. We distribute the negative 2. Now we have 6x minus 6x plus 8 equals 4. The 6x's cancel, and we're left with 8 equals 4, and this is a false statement. A false statement means the two lines are actually parallel, and so they will never touch. There is no solution. Here's another example that seems to give many people trouble. Y equals 5x plus 7, and y equals 7x plus 8. In this example, both equations are already solved for one variable. That variable is y. So we can take either expression and plug it into y in the other equation. When we do that, we're left with 5x plus 7 equals 7x plus 8. And now we need to solve for x. We subtract 7x from both sides. We cancel on the right. We're left with negative 2x plus 7 equals 8. So we subtract 7 from both sides. And we have negative 2x equals 1. We can now divide both sides by negative 2. And we see that x equals negative 1/2. Once we have a value for x, we take that and plug it into one of the two original equations so that we can solve for y. We can take this value and plug it into the first equation. Y equals 5 times negative 1/2 plus 7, which gives us y equals, we can change 5 to 5 over 1. We multiply fractions, numerators together and denominators together, so we have negative 5 over 2 plus 7. And we can also change 7 to 7 over 1. When we get common denominators, we multiply top and bottom by 2 on the second fraction. So we have negative 5 over 2 plus 14 over 2, which will become 9 over 2. Remember, we write this as an ordered pair, so negative 1/2 and positive 9 over 2. Let's try one last example. X equals 9/10 y minus 1, and 20x minus 17y equals negative 18. Again, one of our equations already has one variable alone, so we'll take its expression and plug it into that variable in the next equation. So this will give us 20 times 9 over 10y minus 1 minus 17y equals negative 18. And when we distribute the 20, in the first multiplication, we can think of it as 20 over 1. In the second multiplication, we can think of it as just 20. So that would give us 180 over 10y minus 20 minus 17y equals negative 18. That reduces to 18y minus 20 minus 17y equals negative 18. We combine like terms on the right-hand side, and we have y minus 20 equals negative 18. We add 20 to both sides, and we have y equals 2. Just like before, once we have a y value, we can plug that into one of the original equations and solve for x. So let's do that on the next slide. We can take y equals 2 and plug it into the second equation, for instance. So we multiply 17 and 2. That gives us minus 34. We can then add 34 to both sides. We would be left with 20x equals 16. Once we divide both sides by 20, we have x equals 16 over 20, which would reduce to 4 over 5.